The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Brand Communication Manager for Promat, and I welcome you to another global webinar brought to you by Promat. If you join us from Kuala Lumpur, from Singapore, from Hong Kong, from Sydney, from Auckland, very, very welcome. And those early birds who join us from Europe, because it's 8 o'clock here, also a very warm welcome to you. Today we focus on a very specific and very dramatic topic, and that is how to protect buildings against fire after an earthquake. We all know, of course, that after the earthquake that happened in Turkey and Syria, of course, it is crucial first to save lives, protect people who have lost their homes. And of course, the focus really should be on that topic. Now that we are a couple of months further, the first discussions start about reconstruction. How can we build safer homes, safer buildings for those regions. And this is why we as ProMat want to contribute with our own expertise, and we want to share our expertise, of course, to build a safe and sustainable world. So today we will focus on a very specific topic, and that is how can you do fire protection for buildings in an earthquake risk zone. So if you are building or designing in such a risk zone, this topic will be very, very relevant for you, because it will allow you as an architect or an engineer to design buildings that are not only strong enough to withstand an earthquake, but that will also be safe afterwards, because we all know that after an earthquake, fires break out because of vital services like gas, electricity that are hit, and that creates fires that can damage the building even further. So to discuss this topic and to bring you all the latest insights and also the results of a groundbreaking research, the EcoFire research, I give the floor to Raffaele Gorlezza, our global product manager for ProMat, who is very experienced in fire testing and in fire protection. So the floor is yours.
Thank you, Chris. Good morning, good evening, good afternoon. Indeed, I'm Raffaele Gorlezza. I joined ETEX Group in 2014. Worked for several years in Italy. The last 4 years, I was the technical manager there. And indeed, Italy, it's quite a high seismicity country, so we have done some experience also locally for that. Starting this year, I joined the ProMat Central Division as indeed the Global Product Manager. And today we will go deeper in detail discussing the effect of an earthquake on fire protective material, and which could be the consequences on the fire performance of the building if a fire, of course, occur after the earthquake itself. So first of all, we have to introduce some basic concept about earthquakes. So indeed, earthquakes are much more frequent than we commonly think. According to some statistical data provided by United States Geological Survey, almost 500,000 earthquakes occur in the world of every year, and of which about 100,000 can be felt by human being. Of those, about 100, so luckily as a limited number, cause fatalities and significant damage, but on average we have almost 17,000 deaths per year. And if we look back at our history, basically in the world in the last 120 years, more or less, we have had almost 2 million deaths, neglecting also the loss of goods. You may imagine the consequences of an earthquake also on the society, meaning no more school, maybe no more hospital, homeless people. So earthquake is really a critical event. And I'm based in Italy. Italy, as I said, it's considered a high seismicity country. And if we look at the last 30 years, only in Italy, we have had about 150,000 earthquakes, of which at least 50 of strong intensity, and unfortunately also several diseases after those earthquakes. But where earthquakes generate? So basically here is an animation showing the Earth and the location of all the earthquakes recorded during the last year. As you can observe in the image, basically all the earthquakes concentrate more or less along in the same areas along the crust of the Earth. That's because earthquakes occur along the so-called fault lines. So fault lines are weak points where tectonic plates meets. You know, the Earth, the crust of the Earth is composed by several tectonic plates, which are moving. Some of them are subducting, some are spreading, some are slipping, some are colliding. So there are different kind of movements among the different tectonic plates. But at any case, at the interface of the tectonic plates, there is a fault line, and those movements generate stress. When the stress exceed the friction strength, there is a lot of energy which is stored because of the deformation, and that energy suddenly is released and causes seismic wave and rapid motion of the ground, which indeed cause the earthquake. If we look again at the animation, we see also that not all the earthquakes are at the same depth into the earth. Indeed, it's worth to divide the epicenter of the earthquake, which is the location within the earth at a certain depth at which the earthquake generates and starts from, and the epicenter, which is the vertical projection of that point on the surface earth, where the maximum effect of the earthquake is indeed expected. Why introduce that? Because it's worth to understand better the concept of damages and intensity related to earthquake. So first question, how can we measure the intensity or the power associated to an earthquake? It's not an easy exercise. The first recognized, worldwide recognized method was introduced by Mercalli at the beginning of the 20th centuries. Basically, it's a really empirical method. Indeed, does not require any kind of instrument measurement. Therefore, it could not be so precise in terms of energy associated to the earthquake. However, based on the effect of the earthquake on people, on the landscape, on the building, we can estimate the effect and the power, therefore, of earthquakes, even without any kind of instrumental measurement. And it is really crucial to recreate and understand the story of all the earthquakes and define which are the most seismic zone in the world. Later, again in the 20th century, a more scientific approach, at least in terms of measurement, has been introduced by Richter. So Richter scale and then also moment magnitude scale provide a more precise recording of the energy associated to the earthquake. Concerning Richter scale, it is based basically on the measurement of the amplitude of waves which are recorded by seismograph. So earthquake happen, there are several seismographs all over the world. They can record the earthquakes by showing some movement and measuring the amplitude of those waves and combining the amplitude with the distance from the epicenter of the earthquake. Basically, we can compare all the earthquakes one to each other. Even more precise moment magnitude is an improvement of the Richter scale, measuring again the energy of the earthquake. What is important is that both Richter scale and magnitude scale are logarithmic scale, meaning that they enable to squeeze down in with a few number a high quantity of and a high range of energy which is associated to the earthquakes. Just for you to know, one step on Richter or moment magnitude scale, it's equivalent. It's almost 32 times increase of the energy. If we make 2 steps on the scale, we have almost 1,000 increase of the energy. So it's really huge. Here to give you an example of Mercalli scale. Mercalli scale goes from level 1, which is basically almost no one feel the earthquakes, so very few damages to the natural environment, and that's all, up to there are 12 levels on Mercalli scale, based indeed on observation. If we look, for instance, at the 7th grade of Mercalli scale, there is the frightened of most of the people, some lose, heavy furniture are overturned. Concerning the building environment, the poor building, the ones which are not properly designed, suffer of considerable damages. There are also some important effects on the natural environment, like damage to trees, rock falls, liquefaction of the soil, so quite relevant effect indeed. Just for you to know, if we want to put here the last under Mercalli scale, the last earthquake in Turkey and Syria in 2023, basically it's in the highest grade, so the 12th grade, with almost 60,000 deaths. It is indeed 1.5 million of homeless, and most of the buildings which were totally destroyed. So indeed it was classified as the maximum grade as Mercalli scale. However, Mercalli scale cannot be so precise, because if we are far from the earthquake, the damage are limited, and therefore in the history, if no one was present on a specific zone on the earth, basically the Mercalli scale would give 0, 1, the lowest level. Something different is with moment magnitude, because indeed here it's really energy associated to the earthquake. Here I try to resume a comparison and equivalence between the moment magnitude on the left of the screen with the energy which is associated to the event. Sometimes it's useful or easier to compare with another unit of measure of energy, which are the tons of explosive of TNT. To give you an idea, the sadly well-known little boy, so the atomic bomb which was dropped on Hiroshima during the World War II, was almost 13,000 tons of TNT, so more or less magnitude 6. Again, if we come back to Turkey and Syria earthquake in 2023, so this year, the magnitude was around 7.8, which means basically 1,000 times more, 1,000 times multiplication of the atomic bomb dropped on Hiroshima. So it was really catastrophic earthquake, the one on Turkey and Syria. Another important concept to introduce is the difference between seismic hazard and seismic risk. Indeed, seismic hazard is intrinsic for a specific area. So we understand that earthquake is a natural phenomenon which is generated along a fault line. Therefore, along a fault line, seismic hazard will be very high, because we expect there to occur several earthquakes, even of high intensity. Seismic risk is the probability that an earthquake creates some damage to the building or some loss or injuries to human beings. Therefore, it is associated to our exposition to the seismic hazard. Why is it important to distinguish among the two? Because basically we can do anything to change the intrinsic seismicity, so the seismic hazard of a specific place on the earth. But of course, we can work and we must reduce the number of victims and the damage caused by earthquakes and their consequences. So we can reduce seismic risk. How we can reduce it? Basically by improving the construction system, also increasing the awareness of population authorities on the hazard. Somehow is something which we are trying to do also today. And also we can reduce the seismic risk by modifying the other factor that contributes to the increase in risk and the consequences. Meaning that if we have a fire after an earthquake, the mitigation of fire after an earthquake contributes indeed to reduce the overall seismic risk or the consequences of an earthquake. I just introduced indeed the concept of fire after an earthquake because it's not so unusual. Also in the history, if we read some old ancient written, basically it's not unusual that an earthquake, that a fire happened after an earthquake. Here in the slide you see the most relevant one in the last century. We go from the big earthquake in San Francisco, beginning of the 20th centuries, with almost 52 ignition. And if we look at the earthquake of Tohoku region, for you to know, is of course the one who at the end generated also that big issues with the Fukushima nuclear plant. But following that earthquake, almost 300 ignition started because of the earthquake. The same was for another big earthquake in Kobe, in Japan, again in 1995, with almost 300 ignition, with even a lower powerful magnitude earthquake. So we can see that usually we could see an increase in the ignition during the time, and that is mainly related to the way of constructing building and most of all the services which we have today in our building. Indeed, mainly the fire after an earthquakes are generated by failure of gas pipe or problem to the electric distribution system, electric wires. We also all have fire in the kitchen. We have industrial production process using fire or however using high temperature. And since we do not know when an earthquake will happen, because unfortunately we are not able to predict when an earthquake will happen, basically no one is ready for that. And also potential source of ignition are not saved from the effect of an earthquake. Therefore, it's quite usual that a fire can happen after the earthquake. Again, if we come back to the last earthquake in Syria and Turkey, a big fire started in the port after the earthquake itself. So why it's so important then to focus on the fire effect after an earthquake? Because basically the consequences of the fire following the earthquakes could be much higher than the consequence generated by the same fire on a, let's say, new building. So on a building which did not suffer of an earthquake. And that's because basically, if we have an earthquake, fire may act on an already damaged structure. So the structure itself of the building could be already damaged, and therefore the fire performance of the overall building could be already reduced at the beginning of the fire. Then we have fire protective product and system, which themselves could have been damaged by the earthquake. And therefore, it's worth to look at both active and passive fire protection. Let's imagine if we base our strategy on active fire protection, so I don't know, a sprinkler system, smoke extraction, and then after earthquake, those services are no more able to give their contribution. Passive fire protection as well. If we imagine we create some compartmentation with walls, with ceiling, whatever, but after an earthquake, those compartment elements are damaged. It means that the fire will spread more rapidly all over the building. And also the passive fire protection for structural elements, it's crucial. And we will see later on, it's the main core of our research. Because basically also steel structure deserve special attention. Indeed, steel structure are specifically subjected to high risk in case of fire because of fast heating if they are unprotected, or if protected material is compromised, even a small detachment of the protective material would cause the fast heating of a portion of the structure, which most probably will have a detrimental effect on the whole structure of the building. So we understand that indeed fire after an earthquake can happen. It's not so unusual, which can be really dangerous. So what has been done or what is ongoing at research level? First of all, research level is not easy to target that topic because seismic and fire action traditionally have been considered separately. Main reason are that each of those actions, it's quite complex, even if it's taken alone. Researchers typically are specialized only on one particular field, and also there is lack of experimental facility which enable to test both action together, and also full-scale tests are very expensive and feasible only in very few facilities. Nevertheless, since it's really relevant, European Union decided in the last years, in 2020, to found EcoFire project. Basically, it's a research project involving more than 260 researchers all over the world, with the scope basically to assess the fire performance after earthquake of structural and non-structural element.